Hello everybody and welcome back to another geometry lesson. Today we're starting Unit 2 with section 2.1 on conditional statements. I've mentioned at the start of the year that Unit 2 is going to be a little bit trickier than some of the other units. That's because Unit 2 doesn't deal with a ton of math as we know it. Instead, we're going to be seeing a lot more of what looks to be almost closer to English. The purpose of Unit 2 is for us to be better at using logic and reasoning to help us understand later problems. So we are going to be starting off with some ideas that you may also see in an English class. Today we're starting off with conditional statements. And when we think of a conditional statement, we are talking about a statement that has two parts, a hypothesis and a conclusion. So right here in the notes, I would like us to write that down. Conditional statement is a logical statement that has two parts. A hypothesis, which for the purpose of these notes, you're always going to see me write out in red. And it also has a conclusion, which you're going to see me write out in blue. Hypothesis and conclusion. But when we say hypothesis and conclusion, we don't actually mean the same hypothesis and conclusion that you might see out of a science class. No, when we say a hypothesis and conclusion in a mathematical sense or in a logical sense, this just means a first statement or an initial statement, and then what happens because of that first statement. They're related to each other in that way. So a hypothesis is something that I would like to call the initial condition, the thing that happens first in a statement. I'll give you an example through drawing. Let's say that I drew the following here. I'm drawing myself. There I am. I know it's a very accurate drawing of myself. And I have a green ball that I have just let go of. That's me letting go of the green ball. Me throwing away a green ball or dropping a green ball could be a hypothesis because it's the first thing that happens. So I drop a ball would be a hypothesis. The conclusion is what happens because of that initial action. So the conclusion is what happens based on the hypothesis. I'm going to call the conclusion the result of the hypothesis. If I drop a green ball, what happens? Well, if I drop a green ball, the ball will fall to the ground. Whoop, it goes down like that. The conclusion would be the ball falls. So a conditional statement is one that combines both the initial condition and the result of the hypothesis, which I forgot to put quotes around. In other words, the conditional statement would be something along the lines of, when I drop the ball falls. But we want to standardize it a bit more than just that. There is one way that we are always going to be writing these conditional statements. If-then form. You are always going to write it as if the hypothesis happens, if hypothesis, comma, then conclusion. So for this statement, it would be, if I drop a ball, then the ball falls. Simple enough, right? If I drop a ball, then the ball falls. And in this, we see how our hypothesis and conclusion come together. The hypothesis is here, conclusion is here. If-then form. The one thing that I want to mention before we move forward is this. We oftentimes want to shorten this for the sake of math. I mean, it won't make sense for us to say the sentence, if I drop a ball, then the ball falls, every single time if we're planning on using it a lot. Because of that, we have letters that we can assign, or variables, to the hypothesis and conclusion to help us out. The hypothesis gets the variable P. The conclusion gets the variable Q. So instead of saying any specific examples, we can say, if P, then Q. The mathematical symbol that connects a conditional statement is an arrow that goes from P, from the hypothesis, to Q, the conclusion. This means if P happens, then Q happens. If I drop a ball, then the ball falls. So let's take a look at the bottom of the page here. Let's see if you can fill out these sections here. Take a second, pause the video, and try it out. Hopefully we see that a conditional statement is the one that has two parts. The hypothesis, which I mark in red, and we call P, and a conclusion, which we mark as Q. You might also hear me say the words P implies Q. That just means the same thing as if P, then Q. So let's flip the page. Exercise 1 is underlining the hypothesis of each statement and then circling the conclusion, and then writing it in if-then form. Here's the problem. And here's the reason why we put things in if-then form. English is weird. In English, it's not usually very clear what the hypothesis and the conclusion are. We can say, so sorry y'all, my microphone sort of died on me halfway through that sentence, and I didn't realize it until 2 minutes later. So when we're talking about the hypothesis and conclusion, it can be a little bit hard to distinguish which is which at times. A lot of times in English, we actually have sentences where the conclusion is first and the hypothesis is second. So for instance, you'll have bad breath if you don't brush your teeth is a sentence that we say in English backwards. With these sentences that we're about to see here, many of them are not in a mathematical order. That's why we want to put them in if-then form. So I'll give you a hint for this first one. For this first one, all birds is our hypothesis. What? Mr. Strager, all birds is not a statement. Well, it can be if it's an if-then form. The conclusion is have feathers. So one way we might choose to write it is if something is a bird, then it has feathers. We're allowed to rearrange words, phrases. We're allowed to go in past tense, future tense, present tense, whatever makes the sentence makes sense. As long as your hypothesis is first and your conclusion is second in the if-then statement, it doesn't matter. So knowing this, I'd like us to see if we can try exercise 1. Go through and see if you can rewrite these as if-then statements, then pick out the hypothesis and conclusion. E and F are starred because they're a little bit trickier, but I think you can do it. Go ahead and give it a shot. Pause the video here and try it out. How'd you do? For part B, if you are in Houston, then you are in Texas makes the most sense. It wouldn't make sense if we said, if you are in Texas, then you are in Houston. You could be in Austin or the Rio Grande. For part C, if an angle is 30 degrees, then it is acute makes the most sense. For D, you could kind of do it either way. Either a shape is a pentagon, then it has 5 sides, or if something has 5 sides, then it's a pentagon. Both make sense. E, if it's Wednesday, then we wear pink. It would not make sense to say, if we wear pink, then it's Wednesday, because that statement there implies that just putting on a pink shirt will make it suddenly Wednesday. Same with F. If I'm tired, then I become angry. It wouldn't make much sense the other way around, but you could argue it. You could say, if I'm angry, then I become tired. That would also sort of work. For exercise 2, we want to determine if these statements are true or false. Statements can be true or false. For instance, if an angle is acute, then it has a measure of 30 degrees. If I look at that, I think that's untrue, because just because an angle is acute, that's our hypothesis, doesn't mean that it has to have a measure of 30 degrees, that's our conclusion. An acute angle could be 15 degrees, or 1 degree, or 89 degrees. I'm going to say that this one here is false for that reason. For B, if yesterday was Wednesday, then today is Thursday, that is true in every case I can think of. There has never been a Wednesday that did not have a Thursday after it. So this is true. For part C, this one's one to think about. If a number is divisible by 2, then its last digit is either 2, 4, 6, or 8. So the hypothesis is a number is divisible by 2, then we have to see if its last digit is either 2, 4, 6, or 8. When we say something is divisible by 2, it means it can be divided by 2, right? So what numbers can be divided by 2 but don't end with a 2, 4, 6, or 8? I immediately think of the number 10. 10 is divisible by 2 but is not ending in one of those numbers. It ends in a 0. So this is also false. Let's flip back to the first page, because I've got some more definitions to go through. Statements can be true or false. That also means that some statements can have opposites. This is what we talk about when we talk about the negation of a statement. The negation of a statement is the opposite. And when I say opposite, I want you to put a big asterisk next to it. We'll talk about why in a little bit. It's the opposite, kind of a statement. So I'll give you an example. The opposite of I drop a ball is I do not drop a ball. That would be the negation. Now, we have fancy letters to represent the hypothesis and conclusion. We should also have a fancy symbol to represent a negation. And we do. The opposite of P is called not P, and it has this symbol called a tilde next to it. If you see a tilde, that means the word not. Now that we have that in mind, we can talk about the converse, inverse, and contrapositive. Again, complicated words, but these are just ways that we can change our statements up. Like the negation turned it negative. The converse of a statement flips around its hypothesis and its conclusion. To write the converse of a statement, we literally flip the hypothesis and conclusion around. To write the converse, exchange, or this exchanges the P and Q in a statement. So instead of P implies Q, the converse would be Q implies, this arrow here, P. This is telling us that Q makes P happen. So if our original conditional statement was, if I drop a ball, then the ball falls, we swap these two statements. If the ball falls, then I dropped the ball. Here, the conclusion comes first, and the hypothesis comes second. But it's still a conditional statement. Now, is this true or false? This is actually a false statement. It doesn't quite work, no matter how we phrase it. For instance, maybe I threw the ball. Maybe I didn't drop the ball, but I placed it down so it fell. Maybe the ball was pulled down out of my hands. Just because the ball falls, it doesn't mean that you dropped the ball. If the ball falls, then maybe something else happened. Next up, we have the inverse. The inverse of a statement just negates both the hypothesis and conclusion. It negates the P and Q in a statement. Remember, the negation is sort of like the opposite. So instead of if P, then Q, like we have up here, it would be if not P happens, then not Q happens. If the quote-unquote opposite of P happens, then the opposite of Q happens. So how would we write this statement out? Well, we would want to write it as if I don't drop a ball, then the ball doesn't fall. If I don't drop a ball, then the ball doesn't fall. Sorry, I'm running out of room here. Again, our hypothesis is I don't drop a ball this time, and the ball doesn't fall is the conclusion. But again, this is false for the same reason that the last one is false. Just because you don't drop a ball doesn't mean it doesn't fall. Maybe you throw the ball. Maybe you place it down gently. Maybe you and the ball fall into a pit, and you both fall. You didn't drop it, you're still holding on to it, but it is certainly falling. The converse and the inverse have this weird relationship where both of them will always be the same, whether they're both true or both false. The contrapositive is the last type of change that we're going to make to our statements. The contrapositive is sort of the ultimate change because we are going to both exchange it and negate it. It exchanges and negates P and Q in a statement. So this time we are doing both. We're hitting them with a double whammy. If I drop a ball, then the ball falls. If I flip these two around and made them negative, what would it look like? Well, in terms of symbols at least, we know it would be not Q implies not P. Sort of like this. The not version of Q, the not version of our conclusion, is the ball doesn't fall. So if the ball doesn't fall, then not P is I didn't drop it. I didn't drop the ball. So we can take a look back at this page of our notes, and let's see if we can fill these in. I want you to see if you can fill in these boxes here. Hopefully you recognize this is talking about the negation of a statement. The negation of a statement is the opposite, but with a little asterisk, of that statement. To write the negation of a statement, write a tilde right before the letter. So not P is written as tilde P. The one thing that I want to mention is this. It's this tilde that I've mentioned. Down here, I've added a little bit of a note, just because a lot of people get confused when we talk about the opposite of something. The negation isn't really just the opposite, it's just there's no really good English word to portray what we're looking at here. The negation of I fell down isn't I fell up, just because down and up are opposites. The opposite of I fell down is I did not fall down. The opposite of I bought a cat is not I bought a dog, it's I did not buy a cat. The opposite of I did not enjoy the park wasn't I loved Cedar Point, it was I did enjoy the park. The negation either adds or takes away the word not from a sentence. So take a look at these three examples in exercise 3. I want you to pause the video and see if you can negate these sentences. Remember, we want to include the word not or take away the word not somewhere. Pause the video and see if you can do it. How did we do? If we take a look at exercise A, the opposite of you parked on the left side is you did not park on the left side. It would not be correct if you said you parked on the right side. For B, the opposite of the ball is not pink. The ball is pink. That one's a little more simple. C, though, is a little bit weird. C says, it's not that I don't like the gift. We have to really read into the intentions of the person here. Think about it like this. Let's say that your friend approached you when you were getting ready for school and just went, "Surprise, here's a gift!" And you were scared out of your mind. And they said, "What's the matter? Do you not like my gift?" You might say, "It's not that I don't like the gift. It's that you startled me." The words, "it's not that I don't like the gift," means I like it. It's just there's another thing. So the opposite of I like the gift is I don't like the gift. You could have also written out, if you got rid of the word not here, it's that I don't like the gift, but nobody who speaks English really says that. Or you could also remove the NT from don't, and you could say, it's not that I do like the gift. Both of those have the same message, though. It's that you don't like the gift. Let's flip the page and take a look at the next one. So we've got this sort of diagram here with these 4 boxes. This diagram is one way that we can learn the difference between the converse, inverse, and contrapositive. In order to make this work, I need a sentence that is very much true and is very much a conditional. Pause the video and see if you can think of a good one. We'll come back in about a couple seconds here to see. One conditional that I like is the following. If it rains, then we'll say the ground gets wet. This is a statement that, in general, is true. No matter where you are, if it rains, there is no place where the ground is entirely dry. So if it rains, then the ground gets wet is a true conditional. If we wanted to find the converse of this, the first thing we should do is identify the hypothesis and the conclusion. The hypothesis is what comes after the word if, so it rains is the hypothesis. The ground gets wet is the conclusion. That's why we're able to write this as P implies Q. If we want to find the converse, all we have to do is flip P and Q, or exchange their positions. So the converse would be similar, but it would have Q first and P second. The statement would be Q implies P. What would the converse look like? Well, the converse of the statement would be if the ground is wet, then it rained. Again, I did change the tense of the words, but the meaning is still the same. If the ground is wet, then it rained. Is that true or false? If the ground is wet, then it rained. Well, we might be tempted to say true, but there are a couple cases where that's not necessarily true. Maybe the sprinklers went off, and that's why the ground is wet. Maybe the ground is wet because it snowed and then melted. Maybe there was a monsoon. There are a lot of cases where the ground could be wet, but it didn't rain. So this is a false statement. If the ground is wet, then it rained is not guaranteed, so we say it's false. To make the inverse, all we have to do is negate both our hypothesis and conclusion, P and Q. So the inverse statement would look like this. I'm still going to have my arrow in between P and Q. It's still a conditional. But this time it's not P implies not Q. So if our original statement is, if it rains, then the ground gets wet, what are the negation of those two? If it does not rain, then the ground does not get wet. Again, our hypothesis is first, our conclusion is second, unlike with the converse where we flipped it. Is this true or false? If it does not rain, then the ground does not get wet. Well, for the same reason that the converse was false, this one's also false. If it doesn't rain, it doesn't necessarily mean the ground isn't wet. Again, maybe the sprinklers are off. Maybe it snowed then melted. Maybe there is a monsoon. This is a false statement. Like we mentioned before, there is an inherent link between the converse and the inverse. In both cases that we've shown, they were both false for the same reasons. As it turns out, the converse and inverse will always either both be true or both be false. It's because they're saying the same thing. Let's take a look at the contrapositive. The contrapositive can be found one of two ways. Either I start with a conditional, I flip P and Q so it's backwards, and then I can negate P and Q, sort of like how we did with the inverse, and that'll get me to the contrapositive. So all I need to do is negate the ground is wet and then it rained. Or instead, I could start off by negating P and Q, like I did to find the inverse, and then flip them, like I did with the converse. Either way, this is the idea that we're doing both actions. We're changing it in both ways, flipping it and negating it. And you can do it in whatever order you want. I'm going to choose to go here and then down to the contrapositive. All I need to do then is negate P and Q. If the ground is not wet, then it did not rain. Again, our conclusion is first, or our negated conclusion, I should say, and our negated hypothesis is second. So it'll look like this. The statement is, if not Q, then not P. Is the contrapositive true or false? If the ground is not wet, then it did not rain. As strange as it seems because of all the negatives, this is a true statement. If the ground's not wet, then there's a lot of things that could have happened, but it couldn't have rained. If it rained, the ground would be wet. So, the conditional and the contrapositive are also the same thing. The conditional and its contrapositive also share a truth value. Either they're both true or both false. Granted, you could also have statements that are false, all four of these. All four of them wrong. You could have a statement where all four of them are true. But no matter what, these two and these two will share a truth value. There's a name for this, and that name is actually on our vocab page. So let's flip back to that on page 1. These are called equivalent statements. Equivalent statements is the idea that the converse and inverse or conditional and contrapositive are the same. They're saying the same thing. So if we look back at our examples here, if I drop a ball, then the ball falls, is saying the exact same thing as if I... Where's the contrapositive? If the ball doesn't fall, then I didn't drop the ball. If I drop a ball, then the ball falls. If the ball doesn't fall, then I didn't drop the ball. Similarly, the converse and the inverse are saying the same thing. If the ball falls, then I dropped the ball. If I don't drop a ball, then the ball doesn't fall. A lot of rhymes, so it's a little bit difficult to see, but that's the idea of equivalent statements. The last vocabulary word we have for today is the biconditional. The biconditional is very interesting. It is the most important and most strong truth you can get. Definitions are biconditionals. Things that people say in the court of law can be biconditional. The best truth that you can have is a biconditional. A biconditional happens when a conditional and its converse are both true. When a conditional and its converse are both true, we get a biconditional. We use the words if and only if. So if and only if are used in the sentence instead of if and then. If and only if is used. And I'll show you how that's done in the sentence here. Let's say we're talking about that pentagon example from example 1. Pentagons have 5 sides. As a conditional, we said, if a shape is a pentagon, then it has 5 sides. That's the conditional. But what would the converse be? If something has 5 sides, then it's a pentagon. And that's also true. So we can rewrite this as a conditional. Something is a pentagon if and only if it has 5 sides. This if and only if signals that we're talking about a biconditional. something that is so super true that it works backwards as well. Let's flip over to the next page of our notes where we see the following. Example 4. I want you to try example 4. Then I want you to see if you can fill in the blanks for this. You will probably not be able to fill in this last blank, but we will talk about it here in just a moment. Pause the video and try out example 4 and to fill in as many blanks as you can. How'd you do? So the original statement is, if I study hard, then I will get a good grade. Do you think that's true or false? In most cases, I think it's true. In most cases, I do genuinely believe that studying helps you get better grades. But is it true in all cases? What if you get sick the night before a test? What if you study so hard that you fall asleep in the middle of a test? It's not necessarily true in all cases, so we're going to say that this top statement, our conditional, is starting off on a false note. The converse of this would be, if I get a good grade, then I studied hard. Is that true? Again, maybe. In a lot of cases, I'm sure it's true. But you can still get a good grade and don't study hard. Maybe you just paid a lot of attention in class, you just really understood the content. Maybe you were just very, very lucky and you just absolutely nailed the test without studying. Maybe you cheated and you knew all the answers before you went into a test. There are some cases where you can get a good grade, but not because you studied hard. The inverse is, if I did not study hard, then I will not get a good grade. If we say that the converse is false, we have to say that the inverse is false. Those two are linked together. And again, it's for those same reasons. If you did not study hard, then you will not get a good grade is not true. Maybe you cheated. Maybe you got lucky. Maybe you just really paid attention in class and you know the content without studying hard. For the same reason, these two will have the same truth value. And the contrapositive and conditional will also have the same truth value. We said the conditional was false, so the contrapositive is false. If I did not get a good grade, then I did not study hard. It sounds like you're being too hard on yourself. Just because you didn't get a good grade doesn't mean you didn't study hard. Again, maybe you got sick. Again, maybe something happened. Maybe you fell asleep during a test. Who knows? For that reason, I'm going to personally say that all of these are false, because I have seen a lot of those exceptions. But maybe you believe they're true. This unit is very up to your perception. It's very subjective, is what we call it. If you believe all these are true, I would have graded you correct if you said all true. But you would have to explain why you think they're all true, just like how I explained how they're all false. Down here, if a conditional statement and its converse are both true, we end up with something special, a uniquely strong statement called a biconditional, and strong it is. Instead of writing two statements, we combine the two by using the phrase if and only if. The way we write this in shorthand is, a regular conditional might have an arrow from P to Q. A converse might have an arrow from Q to P. So the biconditional has both. It's an arrow that goes both ways. Looks like a line. So here's an example. If the regular conditional looks like this, and the converse looks like this, the biconditional looks like this. If two lines intersect to form a right angle, that's our hypothesis, then they are perpendicular lines. Okay, I agree. I think that's true. That's the definition of perpendicular lines, right? If two lines are perpendicular lines, then they intersect to form a right angle. This time, we have a conclusion first, and the hypothesis second, and I still agree. I still think that's true. Because they're both true, we combine them and say, two lines intersect to form a right angle if and only if they are perpendicular lines. So the last thing we're going to do for this main lesson here is to try out example 5. Again, we're taking away the words if and then, and putting an if and only if in the middle. So try out these two problems. I'm going to come back to you in just a minute to show you the answers. How'd you do? An angle is a right angle if and only if its measure is 90 degrees, because it works both ways. Two line segments have the same length if and only if they are congruent segments, again because they work both ways. So, this is going to conclude the main portion of our notes. If you are still listening, we are done with the notes that you will be tested on by the end of the unit. However, for this unit, I've included something special. I've had some comments from people who said that they are ready to move on, and a lot of times people will be done with the lesson and we're still talking about it. So I've included some bonus sections at the end of the notes for those students who are ready to move forward into some stuff that we won't be tested on, but might be some important information to know. At this point in time, we're going to talk through the extension and enrichment section of those notes. Truth tables. Truth tables are a way of organizing our thoughts when it comes to things like the conditional, the inverse, the converse, the contrapositive, because they're very difficult to keep track of. We know that a truth value of a statement is either true or false. A truth table lists all of the possibilities for true and false in a table. Every combination is down there. So maybe the hypothesis is true and the conclusion is true. We have that. Maybe we have the hypothesis is true and the conclusion is false. We've got that too. What if the hypothesis is false, but the conclusion is true? Yep, still got it. Finally, what if the hypothesis is false, but the conclusion is false? We've got that in stock as well. They're just in the back. The thing is, that's interesting, is that no matter what, any conditional you have that has a true hypothesis and a true conclusion is an objectively true statement. For instance, if I wear shoes, then I am not walking barefoot. Or, if I drink water, then I will be hydrated. That is an objectively true statement. So we say that that whole conditional has a true value. What if our hypothesis is true, but our conclusion is false? If x equals 1, then x plus 2 equals 1,000,000. That is super false. If x equals 1, then x plus 2 is 3, not 1,000,000. We would give the entire conditional the truth value of false. This is certified not a good statement. Those two make sense. The next two don't. So I want you to bear with me and keep in mind that this is logic and reasoning. It doesn't translate over to English perfectly. Anytime your hypothesis is false, we have to be of the mindset of, then why are we finishing the statement? If you're starting off with something that is false, then no matter what you say afterwards, it is going to be nonsense. For instance, let's look what happens if you have a false hypothesis but a true conclusion. If pink elephants are flying through the sky over the school right now, then 1 plus 1 equals 2. The only thing that I could possibly say to that statement is, sure, you believe that, buddy. If you have a false hypothesis, but a true conclusion, we say that that is a true conditional. Only because if there are pink elephants floating above the school, then anything is fair game. Similarly, if I say, if pink elephants are floating around the school right now, then 1 plus 1 equals 3. Heck, if pink elephants are floating around the school right now, 1 plus 1 could equal window. Yes, we would call that true because if the first thing is happening, then reality as we know it is falling apart. We would give that a value of true. So as weird as it looks, the only time that we would mark something false or conditional false is when its hypothesis is true, but the conclusion is false. This table can be used to help us find other tables, since the converse, inverse, and contrapositive are just swapped around versions and negated versions of the conditional. So if we take a look at the converse here, remember the converse has Q first and then P. So the way we would read this table is, we would read the Q column as our hypothesis and the P column as our conclusion. A true hypothesis and a true conclusion is true, so we're going to mark that here. Uh-oh. What happens if we have a false hypothesis? We've got pink elephants floating around the school. That is something where we will just say, no matter what the value is, we mark it true. Here, we have a true hypothesis and a false conclusion. That is the only time when our conditional is false. So this is our culprit right here. The true Q value and the false P value is false. And the last one, we have a false hypothesis, so who cares? It is going to be marked as true, because if your hypothesis is false, then anything is fair game. The inverse is a little bit more complicatedly written. That's a word, complicatedly. But it means the same thing. We've added columns for not P and not Q, since the whole point of this table is just to reduce the amount of thinking we need to do. If we have the column for P, then the column for not P will all have the opposite values. So if I just exclude these columns here with these markers, notice that the values, are totally flipped. Anything that is true is false. Anything that's false is true. The same can be said for Q and not Q as well. Anything that's true is false. Anything that's false is true. So we can construct the truth table the exact same way. We look to see if there is a true hypothesis but a false conclusion. And this one would be the only case where we have a true hypothesis and a false conclusion, thus making, if not P then not Q, false. I want you to see if you can put together the truth table for the contrapositive. It would help to make the columns for not P and not Q first. Then, use not Q as your hypothesis and not P as your conclusion. Pause the video here and see if you can do it. How'd you do? We see here that the false hypotheses, this one and this one, are automatically true. The one that's both true, the hypothesis and the conclusion, is also true. The only case that's false is when the truth is the hypothesis and the false is the conclusion. You may notice that for some strange reason, the conditional and the contrapositive match perfectly. Wonder why that is? Something to think about and consider your notes on. But that is it for our instruction today. Thank you so much, everybody. Have a fantastic rest of your day.